We discussed question 5 of A-Level Pure Mathematics 2, paper 2 for May and June of year 2020. We are given the graph of a function, and this function has equation y equals x cubed cos 2x. The curve has a maximum at the point M. For part A, show that the x-coordinate of M satisfy the equation where x is the cube root of 1.5x squared cotangent to x. Since M is the maximum point, then the critical number at x can be found by setting dy dx to 0. The critical number is the x-coordinate of M. First, we need to find dy dx. Since y is the product of two functions, one is x cubed and the other one is a trig function, we need to apply the product rule. Applying the product rule, we can whole x cubed differentiate cos to x. The derivative of cos is negative sign, and then we need to apply the chain rule to differentiate the inner function, which is 2x. That gives a value of 2. And now we whole cos to x and then differentiate x cubed. That is 3x squared. From here, we have negative 2x cubed sine 2x plus 3x squared cos 2x as the derivative. The x-coordinate of M can be found by setting dy dx to 0. Then negative 2x cubed sine 2x plus 3x squared cos 2x is 0. And then we will move 1 over to the other side. Let's say we just move this over to the other side. So negative 2x cubed sine 2x is negative 3x squared cos 2x. There are two negatives we can just cancel off to become a positive. Now we divide throughout by 2 sine 2x. We need an x cubed here so that we can take cube root later. So for this case, we are going to divide by 2 sine 2x on both sides. That 2 cancel to be a 1. On the left side, we have x cubed. And on the right, 3 divided by 2 is 1.5x squared. Cos 2x over sine 2x is cotangent to x. Taking cube roots, we have x equals cube root of 1.5x squared cotangent to x. And that is what we are asked to show in part A. Part B, you need to use the equation in part A, meaning that you need to use this equation to show by calculation that the x-coordinate of M lies between 0.59 and 0.6. From this equation, we need to show that the x values that satisfy this equation is in between 0.59 and 0.6. Suppose now x here is the cube root of 1.5x squared cotangent to x. Move this over and we have x minus cube root of 1.5x squared cotangent to x equals 0. So we need to show that the 0 of this function is between 0.59 and 0.6. We can let fx to be x minus cube root of 1.5x squared cotangent to x. If the zero of fx is in between 0.59 and 0.6, then the value of f at 0.59 and the value of f at 0.6 will have different sign. One of them is positive, one of them is negative. Then we know that the zero of this function is in between 0.59 and 0.6. So evaluate f at 0.59. You replace x with 0.59. So for this case, you have 0.59 minus the cube root of 1.5, 0.59, cotangent of 2 times 0.59, and evaluate this. Remember, this 0.59 is a number, not an angle in degree. So you have to use the radian mode in your calculator. Otherwise, you're going to get a wrong answer. So when you evaluate this with your calculator, you get a value of 0.0092, which is negative. And do the same for 0.6. You follow the same technique here. Replace all the x with 0.6. And you should get a value of 0.0057, which is positive. Now let's look at this. If this is the x-axis here, and you have 0.59 and 0.6. The f value is the y value. So the function fx has a y value that is below the x-axis at 0.59. And at 0.6, that function fx has a y value which is positive. Now the function is continuous. When the function is continuous, these two join together. And you see that there is a zero here, meaning that fx is 0 at a point with value in between 0.59 and 0.6. So you need to show these two. Therefore, x here is in between 0.59 and 0.6. Since f of x is in between f of 0.59 and f of 0.6. Then x must be in between 0.59 and 0.6. Part C, we need to use an iterative formula based on the equation in part A to find the x coordinates of M correct to 3 significant figures, and the result of each iteration must be correct to 5 significant figures. Just now we have fx equals x minus cube root of 1.5x squared cotangent to x. And we already know that x here, which is the 0 of fx, this is in between 0.59 and 0.6. We can use the bisection method. So for the first iteration, we let x sub 1 to be, f sub 1 to be the midpoint of 0.59 and 0.6. So that would be 0.595. And just now we know that f of 0.59 is less than fx, which is less than f of 0.6. So we find the value of f at x sub 1. So we evaluate f at 0.595. So you replace x with 0.595 into the function f, and we should get a value of negative 0.0018. So in that case, f of x sub 1 is negative 0.0018. We are going to replace this so that f of 0.595 now is less than fx, and fx is less than f of 0.6. Since this is negative, then we say that the root is 0.595 less than x less than 0.6. To three significance figure, they are not the same. So we have to continue the iteration until these two values are the same to three significant figures. Then we iterate x sub 2. We take the midpoint of these two values here. So that would be the average of 0.595 and 0.6. That gives a value of 0.5975. Now we find the value of f at 0.5975. Just use your calculator, sub it in, and you should get a value of 0.0019. This is positive now, so we are going to replace that. So f of 0.595 is less than fx, which is less than f of 0.5975. Then the root is in between 0.595 and 0.5975. Correct to two decimal places, they are not, correct to three significant figures, they are not the same. So we continue the iteration. We average the two x values here. So we average 0.595 and 0.5975. That would be 0.59625. We find the value of f at 0.59625, and that is 0.00003, which is positive. Then this value is replaced now. We know that f of 0.595 is less than fx, which is less than f of 0.59625. Then x will be in between 0.595 and 0.59625. The three significant figures, they are not the same. We will continue this painful process. Average these two values, and you should get a value of 0.59562. Then evaluate at 0.59562. That is negative 0.0009, which is negative. This is replaced now. So f of 0.59562 is less than fx, and fx is less than 0.59625. So x now is in between 0.59562 and 0.59625. To three significant figures, this is 0.596. To three significant figures, this is 0.596 as well. Therefore, we say that the x-coordinate of m has a value of 0.596 to three significant figures.